So welcome back to part 2 of what do you do if when you do direct substitution and it's undefined. Funny little side note, I made this video once and I forgot to show you my note page. So we're going to give it another shot. So let's take a look now at what happens when you have something that needs to be, rationalized. Okay? So first thing we took a look at was factoring. So now let's take a look at the idea of rationalizing. So what I'm going to do is I'm going to present my screen now so you can actually see what I'm doing and share that with you. And I think it should be popping up about now. So you should see kind of a blank piece of paper, and this is going to be method number 2. This is called rationalizing. Now, you have done this in pre-calc. It's one of those things that I make sure that we kind of get into when we are in pre-calc. So let's talk about how we rationalize an expression. So I'm going to show you 2 problems. So our first problem, I'm going to give you this function. Let's call it h of x. And h of x equals x minus 4 over the square root of x minus 2. And we want to find the limit as x approaches 4 of the function h of x. So we are going to try to figure that value out. Okay? So the first thing you should always do is you should always do direct substitution to start. Okay, so direct substitution, you plug the number in and you see what happens. Now, I'm going to tell you for speed's sake, if you are going to, as soon as you can see that direct substitution gives you the indeterminate form, which is 0 over 0, you don't need to keep going unless they ask you to show it. So in this case, we show 0 over 0 because the square root of 4 is 2. 2 minus 2 is 0. This, again, is called the indeterminate form. As soon as you have that, you know that you can do something to figure it out. In the previous example, we factored. In this example, what we're going to do is we're going to do something called rationalization. So I'm going to rewrite the function right over here, and we're going to review how you rationalize. Okay? If you remember about rationalization, the only thing you can multiply this fraction by is something that is equivalent to the number 1. Okay? So there is a way that you make this number 1. You have to look at the part that has the square root. So if you take a look here, we have the square root of x minus 2. So what you're going to do to rationalize it, you're going to multiply it times the square root of x plus 2 instead of minus 2. But remember, it has to be a value of 1, so you have to do the square root of x plus 2 on the top. Now, there's something really, there's some shortcuts we can take here to kind of make this go a little bit faster. You only need to multiply out the square root part, okay? And if you do this correctly, you'll start to notice a sort of a pattern that happens. So you're not going to have to show a lot of work real fast, but I'm going to show you all of the work, and then we'll talk about what's going to get factored out. So we need to multiply the bottom out. So we're going to do the square root of x times the square root of x. And if you remember, that is equal to x. Now, we also need to do the square root of x times 2. So it's plus 2 times the square root of x. Now we go to the negative 2. So we're going to do negative 2 times the square root of x. So it's negative 2 square root of x. And then we're also going to do negative 2 times positive 2, which is negative 4. So look at what happens when we multiply those out. These middle terms now cancel out. Okay? Now, don't multiply the top out. Just put it as x minus 4 times the square root of x plus 2. You only need to multiply the part out that has the square root. So I'm just going to drop this down, and now we're going to write what we have. We have x minus 4 times the square root of x plus 2 over x minus 4. Look at what happens, okay? This part, the x minus 4, cancels out, okay? Now, think about when you do direct substitution, when you substitute 4 in there, these are the two pieces that cause this fraction to be 0 over 0. Now, what that allows us to do is now we're just going to find the limit using direct substitution of the simplified fraction. And all that's left is the square root of x plus 2. So, for this problem, now do direct substitution. Take this and substitute it in there. So we are going to get the square root of x, or actually the square root of 4, plus 2. So what's our final answer? Square root of 4 is 2, plus 2 is 4. So what is the limit as x approaches 4 for h of x? The limit is 4. This is the process of rationalization, okay? This is what we're doing when we're trying to get rid of the part that is creating the indeterminate form. So now let's take a look at a little different sort of example. So the second example that we're going to take a look at still has a square root in it, but the square root is not in the denominator, it is in the numerator. So let's say I give you this square root of x plus 1 minus 2 over x minus 3, okay? And this is our function, and we want to find the limit as x approaches 3 of this function, and let's call it g of x, okay? So we're going to find this value for this function. So, just like we did before, you do need to do direct substitution and put the numbers in. So I'm going to put 3 in for every x. So we're going to do the square root of 3 plus 1 minus 2 over 3 minus 3. And when you multiply it out, it's 4. Take the square root of it, so it's 2. So 2 minus 2 is 0, and 3 minus 3 is also 0. You have the indeterminate form. So, if you have the indeterminate form and you see a square root, your brain should automatically go to rationalize this fraction. So, I'm going to rewrite out the fraction. We're going to do x plus 1 minus 2 over x minus 3. And we are going to multiply it by a value of 1. Okay? So remember, that value of 1 needs to rationalize, in this case, the numerator. So we're going to use the square root of x plus 1, and we're going to keep everything under the square root, but notice, it's a negative here, so I need to make it a plus 2. And then we're going to multiply it, and then the bottom of the fraction is the square root of x plus 1 plus 2. Okay? Notice, this is a big old value of 1 now, okay? So let's go through and let's do our multiplication. Now, in the numerator, you're going to multiply all of that out. So we are going to now do the square root of x plus 1 times the square root of x plus 1. So that is going to equal x plus 1. Now, the second thing we've got to multiply is the square root of x plus 1 times this 2 way over here. So let's just leave it as is. We're going to do 2 times the square root of x plus 1. Now we need to multiply this negative 2 times the square root of x plus 1. So negative 2 square root of x plus 1. And then we need to multiply the two negative 2's together. So negative 2 and the positive 2, sorry, is negative 4. And then do not multiply the bottom out. Just leave it as x minus 3 times the square root of x plus 1 plus 2. So we need to do a little simplification with the numerator, and then we'll see what happens. So notice, these two parts cancel out because one's a positive, one's a negative. And also notice we have x plus 1 minus 4. So that's going to be x minus 3. And notice in the denominator, we have x minus 3 times the square root of x plus 1 plus 2. So if you did this correctly, that x minus 3 part should cancel out. So what happens now? Now you find the limit as x approaches 3 of what is left over. And the function that's left over is we have 1 over square root of x plus 1 plus 2. This is where direct substitution comes into play. We're now going to take the 3 and substitute it into here. So we're going to have 1 over the square root of 3 plus 1 plus 2. So that's going to equal 1 over 3 plus 1 is 4. Take the square root is 2. 2 plus 2 is 4. So my limit of this function as it approaches 3 is 1/4. Okay? So that is rationalization. That is what rationalization looks like. I hope that you have a pretty good understanding of it. It's a lot of just multiplying stuff out, and there are things that make it faster. So don't multiply everything out. And then some things should just cancel out, and we can figure out the answer. So our next video after this is going to be on simplification, and then those will be the 3 techniques of the 3 algebra techniques to finding limits.